السلام عليكم ورحمة الله. سؤال مخصص أيضا لطلبة المدارس ثنائية اللغة. The two capacitors are connected in parallel as shown in the figure below. The potential difference between the points A and B is 4 volts. The first question is, write two characteristics of capacitors connected in parallel. So for the capacitors are connected in parallel, they have the same voltage. Even if they are 2 or if are 100 capacitors. If they are in parallel, they have the same voltage. Okay, the second characteristic is the total capacitance is the sum of the individual capacitance of the capacitors. So the total capacitance is the sum of the capacitances. And also a third characteristic is the total charge of the system will be the sum of the charge in each capacitor. And also we can say as a characteristic of any capacitors are connected in parallel, the positive plates are connected together. So if this is a positive plate, it will be connected with another positive plate with this wire, and the negative plates are also connected together. This is another characteristic of any capacitors are connected in parallel. So you need only to state two characteristics. Then part B, calculate the total charge of the capacitors. So the total charge is the sum of the individual charges. So we need to calculate Q1 in capacitor 1 and also to calculate Q2 in capacitor C2, then to add them together. Okay. From the law of the capacitance, Q equals to C times V. So if we want to calculate Q1, it will be C1 times V. But what is the potential difference? We go back to the statement here that the potential difference between points A and B is 4 volts. If the potential difference between A and B is 4 volts, that means the potential difference between the plates of C1 is 4 volts, and the potential difference of the C2 or between the plates of C2 is also 4 volts, because we say before that the voltage remain constant for any capacitors are connected in parallel. Then let's proceed. C1 equals to 10 microfarads. So 10 times V is 4. Then 10 times 4 is 40. As long as the 10 is microfarad, the result will be 40 microcoulomb. This is Q1. And for Q2 equals C2 times V. The C2 from here equals to 20 microfarads. So 20 times 4 will be 80, and it is 80 microcoulombs because here the capacitance C2 is microfarads. Therefore, we go here. The total charge is Q total, which is Q1 plus Q2. It will be 40 plus 80. The total charge is 120 microcoulombs. This is the end, but let's check if we have an extra question. Yes, we have here. The question says, Number C, if another capacitor of capacitance C is added in parallel with the capacitors C1 and C2 in the circuit, what will happen to the total energy stored in the capacitors? So we have before C1 and we have C2. We add another capacitor with capacitance C, which is unknown, to the system. What will happen to the total energy stored? The total energy stored could be half CV square, or could be half Q square over C, or could be half what is the last one? If we have C is a Q over V, it will be half QV. But which one of them we should or we must use? As long as they are connected in parallel, so the potential difference remains V, remains 4 volts. We need to choose the one which has a constant value. The constant value here is the potential difference V, so we need to choose the first one to see what will happen to the total energy, because we need to find one of them is constant. This is constant, and when we add the capacitor C, the change will be in the total capacitance. So P E equals to half C V square. When we add the capacitor C here, the potential difference V will be the same, constant, but when we add it, the total capacitance will increase, because the total capacitance of any capacitors added or connected to in parallel, the total capacitance is C1 plus C2 plus C3 plus etc. So the total capacitance C total increases. That means is the total energy stored, PE, will increase. This is the final answer.